Dear students, I am Sandan, working as a physics faculty in Target English Medium School. Today, in this part 2 video, I would like to teach what are the remaining applications of total internal reflection from the chapter of refraction of light at plane surfaces. In our previous video, I clearly explained two applications under the category of applications of T.I.R. That is nothing but what is the looming, and second one, how the mirrors is formed, and in the two cases how the T.I.R. is involved. That is, I clearly explained with a suitable explanation. Now in this part video, the other applications also discussed. These are also important along with the previous two examples. So the third application is brilliance of diamond. So brilliance is nothing but the diamond is appears to more shiny or more brightness when light will be fall on the diamond. That is one. So generally we are observing that if the diamond will be placed at one particular place and when the light will be focused on it, the diamond is appears to more shining. Is it correct or not? Or when you can take the diamond we can rotate slowly and observing that it is appears to more shiny or brightness. That is called brilliance of diamond. What is the reason why the diamond is appears to brilliance or shiny or brightness? That is, so what is the main reason? Means in that one, which phenomena is involved? Total internal reflection. How T.I.R. phenomena is involved in this process, that is we discussed it. So the diamond is appears to more shiny due to the total internal reflection only, because the critical angle of diamond is very less when compared to other denser mediums. We know that in case of glass, water, kerosene, turpentine, whatever that may be. So when compared to that one, we know that the relation between critical angle and refractive index. Refractive index is less, critical angle is more, because of the two are inversely proportional. If refractive index is less, critical angle is more, refractive index is more, critical angle is less. That's why among all denser mediums, diamond has higher refractive index. That's why it has the lower critical angle. When the light, at the same way we know that when you can see the diamond will have the number of refracting surfaces. When the light will be fall on the outer surface of the diamond or the refracting surfaces, the light will be enter inside the diamond and the light rays are trapped inside the diamond due to the lesser critical angle. That's why the light is totally trapped inside the diamond and come outside through one side. That's why it is appears to more shining. Understanding or not? So the diamond is appears to brilliance or shiny or brightness due to the T.I.R. only. How means diamond has number of refracting surfaces. Means like sides are there, different shape is there. The called refracting surfaces. The diamond has number of refracting surfaces. When the light will be fall on their surfaces, light is enter inside the diamond and the entering light inside the diamond is trapped inside due to the lesser critical angle, that is 24.1. is nothing but diamond has lesser critical angle. That's why when the light will be fall onto the refracting surface of the diamond will be trapped inside without coming outside, and after that it will be, for example, just like this one, just we can consider that it is not a diamond shape, just little bit like this one. Here we are observing that what will be happen, how the diamond is appears to shiny, means it is the surface, it is a surface, it is a surface, it is a surface. That's why Okay, in this diagram only, it has how many? 4 surfaces. But when you can see that one, small number of refracting surfaces are there, means it's nothing but glass like that one. That's why if the light will be fall, for example, from this side, when the light will be fall on it. So what will happen when the light is enter into the denser medium? It will be, okay, the diamond has which angle? Lesser critical angle. That's why. So most of the light rays will occurs T.I.R. if light will be fall here and reflected back inside only. Again like this one, and come outside. This one also fall here. Like this one. So means here we are observing that the light rays which are enter into inside the diamond due to the lesser critical angle. What is this one? 24.1 or 24.2 degrees. Due to the lesser critical angle, the light ray is trapped inside. Is nothing but T.I.R. is occurs. And finally, due to the multiple reflections, and the light ray will become outside at a time in the all sides. Is nothing but the emergent light. That's why it is appears to more shiny. Once again, listen very carefully. The diamond is appears to more brilliance or shiny or brightness due to the T.I.R. total internal reflection only. Actually, diamond has number of refracting surfaces. When the light will be fall onto these surfaces, due to the lesser critical angle, the light is trapped inside, that is the T.I.R. And the inside the trapped light ray will be due to the multiple reflections inside and come outside at a time simultaneously from the all sides. That's why it will be appears to more shiny. That is the main reason for the brilliance of diamond. In the brilliance of diamond, which phenomena is involved? T.I.R. Because of due to the lesser critical angle, the light rays are entering inside. They are trapped. Trapped is nothing but no part of the light is not come outside. That is okay, only reflected inside only. That is called trapping. Why inside? That is which phenomena? T.I.R. Why T.I.R. is because it has the lesser critical angle. Understanding? Next one is, and the fourth one, working of optical fiber. It is very important for 2 marks, either working or applications of optical fiber or uses of optical fiber in daily life. So we are discussing 2 modes. So like this one, you are observing that. So here in an optical fiber, generally optical fiber is made up of either plastic or glass. So this it is the just a brief structure of optical fiber. In this one, in an optical fiber, mainly 3 parts are there. One is the core, cladding, and buffer. Generally, optical fiber is made up of plastic or glass. It has mainly three parts: core, cladding, and buffer. Core is nothing but center part or middle part. The core is protected by a cladding or surrounded by a cladding. Further, the cladding is surrounded or protected by, the cladding is surrounded by the buffer. So, what is the use of the cladding and buffer means? The cladding and buffer are protected with one core to avoid the damage. So, actually, the optical fiber means it is very tiny or very narrow, in nanometers of radius is there. Okay, radius of the hole is there, but it is very tiny and you can easily break. It is breakable. That's why. So, to avoid the damage of the core of the optical fiber, okay, for this one, two protecting layers are there. One is the cladding, another one is the buffer. It's nothing but, okay, the core is having two stages of, okay, protection layers. One is the cladding, another one is the buffer. Listen very carefully. Optical fiber is made up of glass or plastic. It has mainly how many parts? Three parts: core, cladding, and buffer. Core is the midpoint and the main part. This core is surrounded by cladding. Further, cladding is surrounded by the buffer. The cladding and buffer are protected. The core is nothing but the core will have the two stages of protection, that is cladding and buffer. But mainly, so what will happen? The information or transmission is passing through only the core. The cladding and buffer is the protecting layers only. It is the part A. Next. So it is the core, it is the cladding, and buffer is above this one is there. We can see that. It is the incident, it is the emergent. So now come to that one. So how the signals are transmitted through the optical fiber, and during such condition, how the T.I.R is involved in the working of optical fiber. That is our concept. So it is the core. Actually, optical fiber is the main uses of optical fiber is to transmit the signals without loss of energy. Is nothing but the accuracy of transmit of signals through the optical by the optical fiber is almostly zero. So generally in the olden days to transmit the signals in the telephone, we are using the wired telephone. So in the wired telephone, what will happen? So when the sound signals are transmitted through the wired one, so in that one mainly two defects are there. One is the loss of audio clarity, and second one is sources are unnecessary sound will be travel along that one. At the same way, loss of sound is also more. And final one is it is trapped very easily. That's why further scientists will be invented this optical fiber. In the optical fiber, what will be happen means that sound signals are transmitted from one place to another place in the form of light signals only. So the light signals cannot be trapped easily by the any mode, because of the sound signals can be transferred into the which one light signals. How means actually a transducer is there. First of all, sound signals are transferred into the electric pulses. The electric pulses further converted into the light signals by using a transducer. Transducer is nothing but it is convert one form of signals to another one. So in a speaker, from the speaker to amplifier, a wired connection is there. From the speaker to from the mic to speaker, a wired connection is there. In this one, so we can produce the sound signals. The sound signals will be transferred through the wire. Means in this one, listen very carefully. In a mic or in a speaker. First in the mic, the sound signals are converted into the electrical pulses. That electrical pulses are electrical signals transferred through the wire and reaches to the speaker. The speaker is the output, mic is the input. In the output of the speaker, the electrical signals further converted into the sound signals. That's why, so when the sound signals are transmitted, or when the sound energy transmitted through the optical fiber, what will be happening means first sound signals are converted into the electrical signals. That electrical signals are further converted into the light signals by using the transducer, and the light signals are traveled through the core of the optical fiber from one place to another place. In this one, there is no other refraction. It's nothing but we know that total light rays will be trapped inside is nothing but by the T.I.R concept, and there is no loss of energy. The accuracy of the energy is very high, or the efficiency of this one is very high. That's why the loss of the sound energy is very less. Due to that one, in the nowadays we are using in the cell phone signals or whatever that may be. So most of the cases we are hearing a clear voice what the other person will be telling to us. That is one. So anyone, how the signals are transmitted through this one means it is a light signal. This light signal will be entered into the optical fiber core. Here one small tiny glass chamber is there. It is a glass chamber, I say that. When the incident light, here listen to this one. When the incident light will fall inside the optical fiber of the core, at that time they must be made, the angle of incident inside the optical fiber must be greater than the critical angle of the optical fiber. We know that what is the critical angle of glass 42. That's why if this optical fiber is made up of the glass or plastic, they are most nearly equal. So that's why if it will be fall on this point, the critical angle of this optical fiber is made up of, for example, glass. What is the critical angle of glass? 42. That's why the incident ray which will be fall inside the optical fiber of the core, they must be made more than the 42. Means is nothing but it is the incident ray. For this point we draw a normal. What is this angle? More than 42 degrees. If we know that when the light is travel from denser medium to rarer, you can mention this part only. This part of the light is where inside the optical fiber. It is a denser medium. When light will be fall here, it will try to come outside. This is the refraction. But here the critical angle, the angle of incident in the denser medium is more than the critical angle. No part of the light is entered into the rarer medium. Total light will be entered into the same denser medium only. That's why the angle of incident means when the light will be incident initially inside the optical fiber of the core, the angle of incident they must be made more than the critical angle. At that time, no part of the light is entered into the other one. It will be reflected back. So means 100% light will be reflected back again here and again. This process will be continuously will happen, and finally the total light energy will become outside. How much light energy will be given? 100%. That 100% will be continuously travel inside and come outside. Mostly here, okay, 99.9% or nearly 99% of the sound signals are transmitted without loss of energy. So it is nothing but, okay, 99 means 1% is negligible. That's why most of the cases we avoid the loss of energy when we can transmit the energy through the optical fiber. That's why in the optical fiber is working based on which concept? T.I.R. concept. Listen once again, listen very carefully. Generally, optical fiber is made up of either plastic or glass. It has mainly three parts: core, cladding and buffer. Core is the main part. This core is surrounded by cladding and buffer. It's nothing but the core is having two stages of protection, cladding and buffer. After that one, we draw this diagram and explain. So when the light, okay, here in this one, during the transmission of signals, during the transmission of any signal through the optical fiber, the signals are first of all converted into the light signals by using the transducer. Then the light signals which is enter into the optical fiber of the core, the angle of incident they made must be greater than the critical angle of that one made up of that material. So then when the light will be fall inside, this angle of incident inside the core is greater than the critical angle of that medium. Due to that, what will be happen? Total light will be, okay, reflected back, and this light will be continuously travel up to, okay, end of the optical fiber, and finally the light will become outside. That's why, so in the optical fiber, T.I.R. is occurs, and with help of the T.I.R. only, so we can transmit the signals without loss of energy from one place to another place. Applications of optical fiber. Optical fibers are used in medical diagnosis like endoscopy, etc. ECG, like that one also. Next one. In defense department, these are used as hydrophones. In producing of seismic waves, and in the process of sonar. These are used in telecommunication. These are used in telecommunication. These are used, means optical fibers are used in broadcast the channels or CAVT. Means channels are broadcast. We are observing that some of the channels will be came from other foreign countries, and the channels you can see in our news TV. So it's nothing but in this one to transmit that TV signals from the abroad countries to our country. So through the electromagnetic waves only. Anyway, so number of are there. Discuss some of that one. Optical fibers are used in medical diagnosis like endoscopy, that one, and in defense department. These are used as a hydrophones in seismic waves and in the process of sonar, sound navigation and ranging. These are used in telecommunication, in mostly in the mobile communication system. Widely we are using which one? Optical fibers. Next, the optical fibers are used to broadcast the channels. Broadcast is nothing but CAVT. To broadcast the channels, from one country to another country, or from So in this one also we are using the which one? Optical fibers. Not one country to another country. Sorry. The optical fibers are used to broadcast the channels. From one place to another place. So that's why these are the number of uses are there for the which one? Optical fibers. So listen very carefully. In this part video, under the applications of T.I.R, we discuss the mainly two in this part video: brilliance of diamond and working of optical fiber. Diamond appears to more shining due to the T.I.R only, because diamond has number of refracting surfaces. When the light will be fall onto their surfaces, due to the lesser critical angle, that is 24.1 degrees, the light is trapped inside the diamond and come outside simultaneously from all the sides. That's why diamond appears to more shining. That is the first thing. And second one, working of optical fiber. Generally, optical fiber is made up of glass or plastic. It has mainly three parts: core, cladding and buffer. Core is the main or central part, and cladding or buffer are protected the core. When the light is entered into the core, means any signals or anything is transmitted through the optical fibers. The signals first of all converted into the light signals by using the transducer. When the light signals is entered into the optical fiber, at that time the incident angle inside the optical fiber must be made more than the angle of incidence. That's why T.I.R occurs inside the fiber, and the light will be travel inside the fiber and come outside. That's why we can avoid the loss of energy by transferring through the optical fiber from one place to another place. That's why inside in this working of optical fiber, T.I.R occurs. And what are the applications of optical fiber? Means number of applications are there. It is used in the medical diagnosis, in the treatment of endoscopy. It is used in the defense department or in army department. So mainly it is used as a hydrophones in the seismic waves and in the process of sonar. Next, it is used for the broadcasting. It is also used for telecommunication in the mobile phones. And also, generally in a single optical fiber, we send nearly 2000 signals at a time. Listen very carefully. 2000 signals are sent at a time in a single optical fiber without much loss of energy from one place to another place.